Vitamin C, also known as ascorbic acid, is a powerful water-soluble vitamin. It is naturally present in certain foods, added to others, and can be taken as a dietary supplement. While ascorbic acid is a naturally occurring organic compound, its synthetic form, L-ascorbic acid, is commonly used in the food industry as a supplement and preservative. Since the human body cannot produce its own vitamin C, it relies on regular consumption of fruits and vegetables as the primary source of this essential nutrient. Vitamin C, or ascorbic acid, serves multiple important functions in the body, which includes enhancing the absorption of iron, calcium, and folic acid, which are essential for various bodily processes. It plays a crucial role in maintaining healthy connective tissues and bones. Vitamin C is also known for preventing scurvy, a disease caused by its deficiency. It is often associated with helping prevent or alleviate cold and flu symptoms. Additionally, vitamin C acts as a reducing agent and coenzyme in several metabolic pathways, supporting various biochemical reactions. Vitamin C is required for tissue growth and repair, as it is involved in collagen synthesis, a vital component of skin, tendons, and blood vessels. Lastly, it acts as an antioxidant, protecting cells from damage caused by harmful free radicals. The two official methods established by the AOAC for analyzing vitamin C are the DCIP titrimetric method and the spectrophotometric method. Ascorbic acid, being highly prone to oxidation, is particularly susceptible to oxidation under high pH conditions and in the presence of certain metal ions like ferric and cupric ions. To prevent oxidation during analysis, it is important to conduct the entire procedure at a low pH. If necessary, a chelating agent can be used to help stabilize the ascorbic acid and protect it from oxidation. When ascorbic acid undergoes mild oxidation, it is converted into dehydroascorbic acid, which still retains biological activity. Dehydroascorbic acid can be converted back into ascorbic acid by treating with reducing agents. This ability to convert between the two forms is significant in understanding the metabolism and function of vitamin C in the body. The analysis of ascorbic acid involves the use of a redox dye called DCPIP. In this method, ascorbic acid acts as a reducing agent and oxidizes itself. Simultaneously, the blue-colored DCPIP dye is reduced by ascorbic acid, resulting in the formation of a colorless compound. The advantage of this method is that it is inexpensive, simple, and quick, making it a reliable option for estimating the amount of ascorbic acid in fruit juices. However, it may be less accurate when dealing with highly colored fruit and vegetable juices. This is because the presence of other pigments in these juices can interfere with the color change of DCPIP, leading to less precise measurements. Therefore, while this method is suitable for general use, caution should be exercised when analyzing juices with high levels of pigments. To prepare analyzing ascorbic acid content in blueberries, start by weighing 5 grams of blueberries and blending them with a mixture of 85 parts methanol and 15 parts hydrochloric acid until a homogeneous mixture is obtained. Centrifuge the mixture at 3500 rpm for 10 minutes to separate the solid particles from the liquid. Carefully collect the red-colored liquid portion and dilute it with distilled water. Transfer the diluted samples to appropriate containers and store them in a refrigerator at 40 degrees Celsius until further analysis. To analyze the ascorbic acid content in blueberries, begin by preparing a 0.05% solution of DCPIP by dissolving DCPIP in distilled water. Next, prepare a solution of L-ascorbic acid by dissolving 0.05 grams of L-ascorbic acid in 60 ml of 20% metaphosphoric acid and dilute it with 250 ml of distilled water. Standardize the DCPIP solution by titrating it with a known concentration of ascorbic acid to establish a relationship between the DCPIP solution and the ascorbic acid content. Finally, take 10 ml of the blueberry solution and titrate it against the standardized DCPIP solution, repeating the titration 3 times. These steps will enable the analysis of the ascorbic acid content in the blueberry solution using the standardized DCPIP solution. This is the formula used to calculate the ascorbic acid content in the blueberry samples. To summarize, the Bricata blueberry variety demonstrated the highest level of ascorbic acid, while the Draper and Duke varieties had slightly lower levels. However, the accuracy of the analysis was compromised due to the difficulty in obtaining clear samples caused by the dark pigmentation of anthocyanins. Using a discoloration compound could have helped address this issue and improve the clarity of the samples. Another method to determine the content of vitamin C is using the UV spectrophotometry method. Firstly, a standard ascorbic acid solution is prepared by dissolving 5 mg of acetic acid in 100 ml of distilled water. Then, the calibration curve of different concentration is prepared. After that, sample extract is prepared by blending the samples and mixing with metaphosphoric acetic acid, and solution is filtered using Wetman filter paper. The clear filtrate obtained is used for determining vitamin C in that sample. To the filtered sample solution, few drops of bromine is added and mixed. After that, few drops of thiourea solution are added. Then, add 1 ml of DNAPH solution to the sample solution and to all the standard calibration curve. Here, coupling reaction occurs due to DNAPH solution. In order to complete the reaction, all the standards and sample solution will start at 37 degrees Celsius for 3 hours. After 3 hours, the solutions were cooled in an ice bath and 5 ml of sulfuric acid was added. As a result, the spectrophotometer reveals colored solutions when measured at specific wavelength. As we can see in the table, it shows the result of ascorbic acid determination in fresh fruits by using UV spectrophotometer. Among the samples taken, blackcurrant has the maximum amount of vitamin C and grapes have the least amount of vitamin C. That's all from us. Thank you for watching.